Good day, viewers. It's another time to study mathematics. Let me first wish you a prosperous New Year 2022. Today, we'll be studying indices. We want to look at the laws of indices. And what is indices on it? What do we mean by indices? Basic laws of indices. We want to look at the examples on each law and the application of those laws. So, we first look at this. Indices is a plural form of index. Index is like a power. It's like an exponential that is raising at a number, or it could be variable. For instance, we can say 2 is the index of 5 in 5 raised to power 2, and 5 is the base of 2. As we can see, 5 is written at the base side, so the power is 2. So also 3 is the index of x in x raised to power 3, and x is the base of 3. So n is the index of a in a raised to power n. A is the base of n. So that is what indices means. So we have all these laws of indices when a, b, m, n, x, and y are natural numbers. So we have all these things hold. Number one, number two. So we'll be looking at them one after the other with examples. First, we look at this. A raised to power m times a raised to power n is equal to a raised to power m plus n. When it is multiplication, the index will change to addition. Just like this example, we're given that 2 raised to power 3 times z raised to power 2 times z raised to power negative 1. So we have the one that happened to be z. So the power will be addition because multiplication is in between them, just like we have it here. 2 raised to power 3 is 2 times 2 times 2, which is 8. Then z raised to power 2 plus negative 1, which is 2 raised z raised to power 2 minus 1, and that becomes z. So we have 8z. Another example is 27 times 3 raised to power negative 1 times 9. When we are given question on indices, let us always express them as possible that they are all in the same base. Just as it is now, we want to make everything to be in the same base so that we can easily add or perform operation of the power together. As it is, multiplication in between them, we're going to add the power together. So 27 is 3 raised to power 3 because it's 3 times 3 times 3. Then 3 raised to power negative 1 times 3 raised to power 2. 9 is 3 raised to power 2. So we can perform the operation on all the power as it is 3 plus negative 1 plus 2, which is 4. So 3 raised to power 4, we can express it numerically to be 3 times 3 times 3 times 3, which is 81. That is it. The second law is a raised to power m divided by a raised to power n equals to a raised to power m minus n. The division in between them will turn to subtraction at the power. So when we ask to simplify y raised to power 4 divided by y raised to power 2, we can easily have it to be y raised to power 4 minus 2, and that becomes y raised to power 2. Another example can come in this manner. The long line in between them is the big division. We should be very careful of it when we are operating that as well. As it is now, we have 2 raised to power x raised to power 2x raised to power 5 divided by x raised to power negative 2, all divided by 6x raised to power 2. So the one at the numerator will first operate it, 2x raised to power 5 minus negative 2. And minus negative 2 is going to be positive, just as we have seen it here. So it's going to be 2x raised to power 5 plus 2 divided by 6x raised to power 2. And that becomes 2x raised to power 7 divided by 6x raised to power 2. So we're going to have it to be 2 over 6 will become 1 over 3. Then x raised to power 7 divided by x raised to power 2, it becomes x raised to power 7 minus 2. Division changes to negative sign at the power. So and that concludes to have 1 over 3 x raised to power 5. So another one we have is a raised to power m into n equals to a raised to power n into m equals to a raised to power m n, meaning that we can perform operations of multiplication at the power as well. Just like we have it here, 3 raised to power 2 into 3 divided by 81. So that what we have at the power can easily operate themselves, and it can easily become 3 raised to power 6 divided by 81. 81 as well can also be expressed as 3 raised to power 4. That is 3 times 3 times 3 times 3. And that becomes 3 raised to power 6 minus 4, which is 3 raised to power 2. And it's simplified to be 3 times 3, which is 9. So we also have another example, 5 raised to power 4 into 2 times 25 raised to power negative 1. That 25 can also be expressed as 5 raised to power 2, which we can easily perform. Already we have done that of 4 times 2, which is 8. Then 5 raised to power 2 into negative 1. And 2 times negative 1 is going to be negative 2. And we can perform the power once they have the same base now. 5 raised to power 8 minus 2, which is 5 raised to power 6. And we can numerically have the result to be 15,625. Let's look at another example. This one is when it's showing an example on when a raised to power 0, a raised to power 0 equals to 1. That a can assume number. Any number raised to power 0 always becomes 1. And let us look at this, what we're asked to simplify. 3 raised to power negative 2 into 3 raised to power negative 2 into 4 times 243 divided by 3 raised to power negative 5. As we have it here, we can make all the base to be the same. We're expressing all the base to be the same, like 243 can be 3 raised to power 5. That is what we just did now. And we equally operate negative 2 times 4, the power at that 3 inside the bracket, which is negative 8. We proceed to have 3 raised to power negative 2 minus 8, the one at the power of the first 3, times 3 raised to power 5 minus negative 5, because it is division in between them, and that makes it to become minus. So minus 2 minus 8, that will become negative 10. That is why we have 3 raised to power negative 10. Then then 5 minus 5, that becomes 5 plus 5, which is going to be 10 as well. So when we have 3 raised to power negative 10 times 3 raised to power 10, we can operate that 2 together, meaning that minus 10 plus 10 becomes 0. And when we have 3 raised to power 0, it becomes 1. Another example of that is when we have 49 raised to power 7 times 7 raised to power negative 14. We can have this to be 7 raised to power 2 into 7 times 7 raised to power negative 14. 7 raised to power 2 into 7 can be 7 raised to power 14 times 7 raised to power negative 14. So the power at both base, we perform them together and it becomes 0. That makes it to be 7 raised to power 0 and it will be 1. Let's look at another example when we have 81 over 1. This is 81 over 10,000. The law we are following here is that when we have a over b into power of m is equal to a raised to power m over b raised to power m. And that is the same operation we have performed here. We express 81 as 3 raised to power 4 and 10,000 as 10 raised to power 4. And because they both have the same power, we can factorize it out to have it at its power. And that is how it is. We can have another example. This example, please, we have to look at this very carefully because we have two variables and we have some numbers to perform operation on. Look at it as it is. X raised to power negative 8 over 8y into 2x raised to power negative 2y square over x raised to power negative 3 y raised to power 4 all raised to power 3. What we do first here is that the one inside the bracket, we simplify it and we operate that long division. We turn it to minus sign when it goes up. That 2 is there. X raised to power negative 2 is also there. Then x raised to power negative 3 at the denominator now becomes minus negative 3 at the power. Also, y raised to power 4 at the denominator now becomes minus 4 at the power. And that is how we have it. The raised to power 3 is still there old. So we proceed to simplify the one in the bracket when we have x raised to power negative 2 minus negative 3. So that becomes minus times minus is plus. Minus 2 plus 3, that becomes 1. So and that's why we have it x. Then the second one is y raised to power 2 raised to power y raised to power 2 minus 4. And that becomes y raised to power negative 2, just like we have inside the bracket. So the 3 is still outside. We have to be very careful of that. After that, the 3 outside, we can now use it to operate what we have inside. 3, that power of 3 on 2, it's going to be 8. 2 times 2 times 2, that is 8. That power of 3 on x, it's going to be x raised to power 3. That power of 3 on y, because we have negative 2 on it before, we're going to have negative 2 times 3, and it becomes negative 6. That's what we have. We can now see that that 8 inside the bracket can easily cancel out the 8 at the denominator outside the bracket. Then we can have x raised to power negative 8 plus 3, because 3 is at the power of x inside the bracket, y raised to power negative 6, the one inside the bracket, minus 1, that power of y at the denominator. That is how we have this. Then we simplify it to have x raised to power negative 5, y raised to power negative 7, because minus 8 plus 3 is negative 5, minus 6 minus 1 is negative 7. So we can re-express this as 1 over x raised to power 5, y raised to power 7 as it is. This is indeed the next law that we're going to look at. That when we have a raised to power negative m, it can also be expressed as 1 over a raised to power m, which we have just done in the previous example. So this is the similar sample to what we just did right now. So we'll proceed to the next one. Something like this: a raised to power a over b all raised to power negative m can equally be expressed as b over a all raised to power m. Please take note of this. There is a reciprocal. The reciprocal of that fraction is being used. Meanwhile, it has removed the negative index. So that is the change that we need to study here. The same thing, we're going to apply it to this example. 343 over 125 all raised to power negative 2 over 3. Then we can simplify that to be 7 raised to power 3 over 5 raised to power 3, because 343 is expressed as 7 raised to power 3. So also 125 is expressed as 5 raised to power 3. And because they have the same power, we can easily factorize that out, and we use it to multiply that negative 2 over 3, which is the power. So 3 will cancel out 3, and what we'll be having left is 7 over 5 all raised to power negative 2. And with that, coming to apply the law now, we're going to have 5 over 7 raised to power 2. So it will no more be negative 2. It will now be positive 2. Then we can re-express and simplify it. 5 raised to power 2 over 7 raised to power 2, which is 25 over 49. Let's look at the next example. 36 raised to power 1 over 4 times 216 raised to power 1 over 12 times 1 over 6 raised to power 1 over 4. Looking at this law, just always look at the law at the top right corner of the screen. Root a is equal to a raised to power 1 over 2 is the same thing as squared the squared root of a. That's what they call it, square root of a. So we want to simplify that, and this 36 can be expressed as 6 raised to power 2 into power of 1 over 4 times 6 raised to power 3. 216 is 6 raised to power 3, that is 6 times 6 times 6, into power of 1 over 12 times 6 raised to power negative 1 over 4, being the fact that we have it at 1 over 6 raised to power 4. So this is an application to the previous law we just treated, that we can express it as 6 raised to power negative 1 over 4. Then they are all in the same base, and we can perform operation on their power. As it is, 2 times 1 over 4 becomes 1 over 2. 3 times 1 over 12 becomes 1 over 4. And we have negative 1 over 4 as it is. So we can now add the base together. 1 over 2 plus 1 over 4 minus 1 over 4. So, and when we simplify that, we're going to have 6 raised to power 1 over 2, which is the same thing as root 6. So we just apply that law we have. So the next one is a raised to power 1 over n is equal to nth root of a. Nth root of a. So we can have that to be expressed as, when we have 3 when we have cube root of 27b raised to power 6, that would operate the two all the magnitude inside that root value. So it's going to be 1 over 3. It's going to be 1 over 3 at the power. And please, we have to be very careful at this. That 27 can be re-expressed as, or we can even use that 1 over 3 at the power to evaluate them one by one. So that 1 over 3 at the power can go with 27, can equally go with b raised to power 6 as well. And 27 can be expressed as 3 raised to power 3, and that would simplify to divide the 3 by 3. Then it will be 3 raised to power 1, which is 3. And that 6 at the power of b as well would divide that 3, and that makes it b squared. So we have 3b squared as the final answer. Let us take a look at the next example. As it is, a raised to power x over y is equal to white root of a raised to power x. So, and please take a careful look at this example. The question is asking us to simplify cube root of m raised to power 2 times m raised to power 1 over 3 times root m. What we have here is that all the bases are common, fine, and we can perform operation of the power as it is. That cube root of m raised to power 2 will become m raised to power 2 over 3 times m raised to power 1 over 3 times m raised to power 1 over 2. That root m is the same thing as m raised to power 1 over 2. Now we can perform operation on the power. The first two power, which is 2 over 3 and 1 over 3, is what we have just added together. 2 over 3 plus 1 over 3 is going to be 1, and that is the power on the first two m. So the second m, which is m raised to power 1 over 2, is what we can further simplify like m times m raised to power 1 over 2, it can be re-expressed as m root m, or we proceed to have m raised to power 3 over 2. What is being done here is that the power on the first m is 1, the power on the second m is 1 over 2. We can add the power together, 1 plus 1 over 2, that will be 3 over 2. So we have subsequent laws, and this law would make use of them in indicial equation. If a raised to power n is equals to b raised to power n, and a is not equal to b, then n is equal to 0. Another one is if a raised to power m is equals to a raised to power n, then we can say m is equal to n. So when we look at this very carefully, do not worry, on the next video we're going to have indicial equation in details, and we'll solve enough examples to explain and do justice to this. Thank you so much for listening. Do have a nice time.